Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. In E2 elimination, a base removes a beta hydrogen antiperiplanar to the leaving group, Br, forming an alkene. We count all distinct alkene products including geometric, CIS trans or EZ, stereoisomers. A. CH3, CH2, CH2, CH2 Br, 1 bromobutane. Only one type of beta carbon, C2, and elimination gives 1 butene, CH3, CH2, CH is equal to CH2. There is only one possible alkene product, with no geometric isomerism possible, terminal alkene. Number of products is equal to 1. Matches, P. B. CH3, CH, Br, CH2, CH3, to bromobutane. Beta carbons are C1, CH3, and C3, CH to CH3. Elimination towards C1 gives 1 butene, CH2 is equal to CH, CH2, CH3, no geometric isomerism, terminal. Elimination towards C3 gives 2 butene, CH3, CH is equal to CH, CH3, which has CIS and trans isomers. Total products, 1 butene plus CIS, 2 butene plus trans, 2 butene is equal to 3 products. Matches are C, CH3, C, CH3, Br, CH2, CH3, 2 bromo, 2 methylbutane. Beta carbons are C1, the 2 equivalent CH3 groups on C2. Weight, the structure is C1 is equal to CH3, C2 is equal to C, CH3, Br, C3 is equal to CH2, C4 is equal to CH3. Actually the molecule is 2-bromo, 2-methylbutane, CH3, C, Br, CH3, CH2, CH3. Beta carbons, C1, the methyl attached to C to giving isobutylene type product, and C3, CH to CH3 side. Elimination towards C1 methyl groups gives 2-methyl but 1-Na, CH2 is equal to C, CH3, CH2, CH3. No geometric isomerism. Elimination towards C3 gives 2-methyl but 2-Na, CH3, C, CH3 is equal to CH, CH3. This has no geometric isomerism since one side has 2 identical groups. Actually CH3C, CH3 is equal to CH-CH3. The 2 sides of the double bond are C, CH3, 2 and CH-CH3. No CIS trans possible since the left carbon has 2 methyl groups. Weight, recounting, products are 2-methyl but 1-Na and 2-methyl but 2-Na is equal to 2 products. Matches, Q. D. pH CH2CH, Br, CH2CH3, 1 phenyl 2 bromobutane. Beta carbons are C1, PHCH2, and C3, CH2CH3. Elimination towards C1, PHCH to gives PHCH is equal to CH, CH2CH3, 1 phenyl 1 butene, which has CIS and trans isomers is equal to 2 products. Elimination towards C3 gives pH, CH2CH is equal to CH, CH3, but 2Na with phenethyl, which also has CIS and trans isomers is equal to 2 products. Total products, 2 plus 2 equals 4 products. Matches S. Summary. A, P, 1 product. B, R, 3 products. C, Q, 2 products. D, S, 4 products. Therefore, the correct answer is A, P, B, R, C, Q, D, S. Therefore, the correct matching is A matches P, B matches R, C matches Q, D matches S.